Tagadan 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 pam pam tagadan 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 pam pam tagadan 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 pam pam tagadan.
Perfect. So, hello everybody. I'm Massimo Benini from CSCS, and today I'm gonna talk about FENIX, which is a federated authentication and authorization infrastructure. So, first of all, let's give a little bit of background about what FENIX is and its mission. So, FENIX is an initiative between several European HPC centers. It all started around 2018, so initially between Cineca, BSC, GSC, and CSCS. And the aim of FENIX is a collaboration between those peer centers in order to harmonize their offering of infrastructure services with the goal of supporting a larger variety of science and engineering community. So what does it mean? So it means that the goal of the infrastructure is for the user of this community to provide a seamless access to different services offered by the HPC center. So for instance, not going through yet another registration process or authenticating only once against their own trusted identity provider. And then the user can have access to all the resources he owns across all the services offered by the FENIX community. So FENIX has the ambition of serving in a sustainable manner relevant science and engineering domains that strongly benefit from these diverse infrastructure services for their collaborative research. So in other words, this means that hosting sites need to maintain their independence and keep functioning regardless the status of the federation. But also that this community will benefit a lot of the composable interoperability of different infrastructure. But I will do more example later. So at the end, FENIX is a collaboration of different infrastructure service providers, which leverage national, European, and international funding program, ICI, to realize the compute, the storage, and the network resources sustaining the infrastructure services. So here, I would like to remark some basic FENIX concepts. So FENIX is a service for multiple user communities and must be easily extendable to other possible future communities, for instance, eBrains or Praise and other infrastructure. It provides federated infrastructure services to support community-specific platform services. As example, the eBrains service platform, which I will gonna give you some example later. It is a federated infrastructure layer on top of composable services. For instance, one community can build their infrastructure, they can build their platform based upon resources spread across multiple sites. And it's also support different site local implementation to avoid technology vendor lock. So let's make some example of platform services built on FENIX infrastructure. So I choose three eBrains platform that are of value for this example. So the first one is the Data and Knowledge Service, which is a platform that facilitates the neuroscience research and discovery, providing online solution for sharing and access to research data, computational models, and software. So the service revolves around an expert-driven knowledge graph, which combines metadata ingestion pipelines, human users input, and multiple quality assurance processes to help contributors and users by ensuring data consistency and quality. On the FENIX side, the relevant resources are for this kind of a platform are the archival data repository, example, Swift object storage, and the virtual machine service, cloud resources. So another Example of platform is the eBrain's neurorobotic platforms, which is a simulation framework that enables in silico experimentation and embodiment of brain models inside virtual agents interacting with realistic simulated environment. This platform makes use of scalable computing service on the HPC host sites, so traditional classical HPC and virtual machine service. So they combine both of these services. The third one is the Atlas service, which is a three-dimensional atlas that integrates different facets of the human brain organization. So, and in terms of FENIX, this is the more complete platform because it uses all the possible infrastructure categories. So we have archival and active data repository, scalable interactive computing, and cloud services. Here is an overview of all the possible composable services provided by the HPC's partners and glue aggregated together by the FENIX infrastructure. So as you can see, we have active data repository, which is, in other words, global parallel file system, scalable interactive computing, which is provided typically by Slurm or other resource manager. And then we have cloud environments. So generally, at the moment, are provided by OpenStack platform hosted at the various sites, or there can be also container orchestration services like Kubernetes and so on. Again, with archival data repository, we mean, for instance, object storage, so non-POSIX implementation like Swift. Which are the benefits of this federation? So the principal benefits is having a unique authentication support accessible for a very large number of users. So it facilitates the exploitation of data locality and provides access to storage and compute resources, which are geographically distributed. Also, workload resiliency is improved because imagine hosting a website distributed across geographically different physical places. And for instance, we have maintenance on site A. So all the services can be moved to site B in a reliable manner. Another remarkable benefit is that you increase the chance that more resources and services are added to the set of the services offered by the federation. So I've talked about the principle driving the federation, but let's dig down to the design and the real implementation. So what we wanted to do was to create a federation of identity providers, establishing a central proxy that collects all the authentication requests and an attribute provider, which stores authorization records. It is important to rely on standards, authentication authorization protocols like SAML 2.0 and OpenID or OAuth 2 in order to ensure the best interoperability between all the identity providers. So the solution should manage user profile and assert basic attributes to ensure the presence and the validity of the users, because we have users coming from different identity providers. So another important aspect we took in consideration when we designed the federation was again that all the sites have to remain independent from the federation and keep functioning regardless the status of the central proxy or the central attribute provider. So every site where the service provider are hosted must or can implement local access or security policy and enhance protection on their services and applying a fine-grained access control. So we want to have this border. As I said, the federation layer is made of two components. So one is the central proxy and the attribute provider. So I will refer as a firm. So firm stands for FENIX User Resource and Management Service. And its role is to store and manage attributes, including user-related attributes, but it is also a place for managing global resource allocation and relative consumption data in a distributed environment. So it will keep and store all the values of the quota of the resources spread across all the sites. So this is an architectural schema of the solution where on top we have all the identity providers plus potentially the original identity provider plus potentially other identity providers. For instance, HBP, Human Brain Project identity provider has been already included. In the middle, we have the central proxy, which collects all the authentication requests and proxy this request to the various identity provider. On the right, there is forms, which is providing a REST API layer where the service provider can fetch the attributes about resources quota and authorization and report back the data about resources consumption. So the central proxy has also the ability to enrich the attributes provided by the identity provider of the user choice, adding, for example, information if a policy disclaimer of a certain service has been acknowledged by a user or other solution. And then the service provider can decide if allow the user to use the service or not. And on the bottom layer, we see the various service provider with the protocol of their choice. So more detail about the central proxy component. So it is basically proxy the authentication request to the identity provider selected by the user. Each user has a profile on it, and it is validated by the proxy. So user can link multiple authentication profile into one, because it can be the case that a user has multiple accounts on various identity provider, and they can be linked centrally in the central proxy identity provider. And then in here we implemented the concept of level of assurance. So in identity management, assurance level means a level of confidence in the binding between an entity, a user, and the presented identity information. So the assurance levels in this case is determined by the user's home organization, who issue and manage the user identities and carries out the user authentication. So we define 3 levels of assurance. So in the highest one, level high, it's for user authenticated through the original identity provider of the FENIX site. A medium level, which is if a user is authenticated through an identity provider that comes from the platform that are using the services, and other, which it's not implemented at the moment. Another information about forms. So FENIX sites provide resources of various types to FENIX for consumption by the communities, which in turn distribute the resources to their project. So resources at the site can be consumed up to the amount provided by each site, and the consumption will be reported back to firms for accounting purposes. It will then help manage the allocation of resources to the various registered communities and projects. And the model is such that resources are made available by the site in terms of FENIX credits. So FENIX credits represent unit of value for consuming specific resources at a specific site. So as example, any resource, they comprise of four attributes, which is the type, for instance, scalable compute resource, the amount of this resource, for instance, the number of cores per hours, which create the credits, the FENIX resource provider, so in which site this resource can be consumed, and a validity period. So in this essence, Forms is a generic attribute provider. Is it also a service provider itself? Because, for example, the the PI, the principal investigator of a project can invite collaborators from full portals. It also has a web portal, and each collaborator will then be notified via email about the new membership and is requested to validate it by accessing two forms. So which kind of attribute it stores? It can store several kind of attributes. It can store user SSH keys, for instance, or group membership attributes. And also the service provider, they should report back to forms through an API called by specific local agent, the consumption of a resource in a specific site. And then the global consumption across all sites will be aggregated into forms. So on forms, we introduced the concept of a virtual organization, which is it's a word coming from the grid computing world. And it's like a project, but spread across different sites where the project has resources. When we designed for, we wanted to be a one-stop shop. We designed it with a one-stop shop approach, where user and administrator of the services can deal with membership management, resource allocation, accounting, and also for policy documents management. So what does it mean? It means that administrator of a services can load the policy disclaimer for a service and manage the acknowledgement for the policy documents by the users. On form is kept the information if a particular policy has been acknowledged by a user or not. So for instance, let's say that after accessing OpenStack on site A, the user is redirected to the central proxy where he can select his own identity provider. After authentication, is redirected back to the central FENIX proxy. Here, if the user has not yet accepted the current version of the FENIX access policy, see a disclaimer. For instance, is a first-time user. So the FENIX central identity proxy presents the user with the FENIX access policy and ask him to accept it. So at this point, the user must accept the policy by ticking a checkbox, and his profile is now created in the central proxy. Once it's created, a new identifier and FENIX username are created in the FENIX central proxy. And from now onward, the FENIX identity provider will retain a copy of the user profile. And the user will be definitely considered a valid FENIX user. In case of policy document get updates, users need to acknowledge these updates upon their next login before proceeding to use any resources of the site or site that have updates policy document. So this can easily be achieved when user login via web-based interface, so by ticking on a disclaimer. However, it is the responsibility of the service operator at the individual site how the user is informed about a missing acknowledgement. So the same holds for user login in via SSH, where a respective message should be displayed to the user. So ideally including a link to follow for the acknowledgement. And again, this is a responsibility of the site operator. So with this slide, I just want to share the concept that the idea that once we have our federated of identity up and running, for instance, one of these blue box, it is possible to expand it even more and put together other identity federation and create a level up of federation of identities. So when you provide a common AI service, we can aggregate the different identity federation. And this means that to facilitate the access to resources to always a bigger and broader audience. So now briefly, some technical challenges we've been faced during those years. So first question when we met was who's hosting this FENIX Federation and who is in charge of developing it and maintaining it. So for the central proxy, Giant was the perfect match. So it already has developed and maintained over the years several other identity federation communities, and it's a trustworthy organization. So GEANT, for those who don't know, is the collaboration of European national research and educational networks. And its mission is to deliver an information ecosystem of infrastructure and services to advance research, education, and innovation on a global scale. While FORMS, the other services, will be hosted by ULIC. So account linking. So each user may potentially, as I said before, may potentially have multiple accounts within the FENIX Federation and use different identity providers to authenticate. So the FENIX central proxy needs to really carefully handle this situation in order to avoid the creation of multiple FENIX accounts. So all the user accounts of different hosted sites must be mapped to a unique FENIX identity to avoid the proliferation of accounts, of identities. So we have two possible options for mapping the accounts, and we choose the email over the person principal name. So this means that the bare minimum set of attributes that an EDP must release is a unique email. So when we use this authentication method, modern method like OIDC, OpenID, so they work fine with the web, but when you have to deal with command line clients, for instance, it's more cumbersome. So that's why we have to use a special feature of the protocols to overcome problems that we have. So for instance, in this diagram is shown how to handle OpenStack authentication within Federation. So exploiting the token introspection endpoint provided by the central proxy. So we have Keystone. Keystone is the authentication component of OpenStack, which can rely on third-party authentication methods. And in this use case, we want to exploit the fact that a user already has a valid access token obtained after a valid authentication through an identity provider, which is part of the FENIX infrastructure, for instance, a CSCS identity provider. So once the user has his access token, this is presented to Keystone via command line, and Keystone is forwarding it to the central proxy in the introspection endpoint. The central proxy can read the JWT token and recognize it's coming from a well-known identity provider, where it knows its token introspection endpoint. So on point 7 and 8, the central proxy is contacting the identity provider with the token for introspection, and then the identity provider can confirm back to Keystone about the validity of the token. So at this moment, from this moment on, the user can then issue OpenStack commands using an access token issued by one of the identity provider of the Federation. Another interesting case and feature of the OIDC is the token exchange. Token exchange is an extension of OIDC that allows an application to exchange a token and receive during a user login for a new token that is accepted by a different OIDC application. So in the OIDC terminology, this is called delegation. So the new token might be an access token that is more narrowly scoped for a downstream service, or could be an entirely different kind of token. One example of a service using this feature is as a service of the Federation using this feature is FTS3, which is a data transfer service for object storage developed by Stern. So this service will use an authentication token obtained by the user who wants to transfer, let's say, object A from site A to object B on site B. And it does that, exchanging the user token with two different tokens used for the transfer. So a very, very quick demo, just to show how to facilitate the life of the user. So for instance, we are showing a user that wants to access OpenStack Horizon, the dashboard on the CSCS site. So it does not have an account on CSCS, but it has an account on one of the other sites of FENIX. He will go to FENIX, for instance, and choose his Cineca identity provider, authenticates there, and with the Cineca account, he can access Castor, because on Castor he has some resources there. Because he already authenticated through an identity provider of the Federation, if we go back to and open another tab with the OpenStack at Cineca, it doesn't need to log in again, because he is transparent for him. He already authenticated once, and this is the OpenStack of Cineca. So, as conclusion, so FENIX is a long-term effort of Supercomputing Center to provide a variety of infrastructure services. So its aim is to support and foster diverse science and engineering communities in their effort to deploy domain-specific platform services, like what I've shown with the eBrain. And with this, I think it's all. Thanks for the attention.
Thank you, Massimo, and thank you for stepping in. I do have one question from Gerardo saying sorry. I should have read the question first. That was probably just to me. Hussein, do you have any questions for Hussein? I mean, do you have any questions for Massimo? I'm all kind of flushed up now.
Well, I'm quite familiar with it, but what I would like to ask Massimo is that what do you think the missing features of the federations? With all the work have been done, you have been working in different levels, and do you think that there are key features that need to be implemented and that to have like a more completed federation?
So it's not more about having key feature, because I think we were able to demo and showcase all the key features, but now I think we have to implement workflow. For instance, everything that is related to web, it's working perfectly, but things like that use CLI, we need a little bit of more work. And sometimes we need to develop and adapt script of tools that we are already using, and then Forms is I think is not fully implemented. So right now in production there is only the central proxy. So Forms will come in short.
Yeah, so in a different word, all the cloud parts, which is users are like similar to what cloud providers are delivering, these are completed. However, when it comes to CLI case, one of them we were discussing early this morning, is there's some limitation and requires more attention and more work to be able to offer similar to what the cloud part is offering.
Exactly. I would not say the word limitation, but yeah, they may need some more attention. Yeah. It's not straightforward always, but it's doable anyway.
Thank you.
Thanks.
Okay, thank you, Massimo. Appreciate the presentation for stepping in.